welcome back. So last time, the previous video, we saw how we could take the generating function of the Fibonacci sequence, and we saw that there was another way that we could get to it using x over 1 minus x squared, which we saw was also equal to the sum from n equals 0 to infinity, sum from k equals 0 to infinity, n choose k, x to the n plus k plus 1. And I think it's worth taking a little bit of a detour here because we need to be sure that we're comfortable with first of all, I made a mistake here. This should be the sum from k equals 0 to n, not the sum from k equals 0 to infinity. And this one, I think we should spend a little bit of time thinking about what it looks like and what it means to have a summation that looks like this. So one way that it might be helpful for us to get started visualizing this is to realize, first of all, that there's an outer sum and an inner sum. So this is a sum of a bunch of terms, and it just so happens that each term is itself a sum. So if you're thinking about that in terms of writing it out, you're going to start with n equals 0, and you're going to say, well, what term do I get when n is equal to 0? And what I get is the sum from k equals 0 to n, which in this case is 0. And in this case, we're looking at 0, choose k, x to the 0 plus k plus 1. So there's only one term because I'm going from 0 to 0, so this is 0, choose 0. And here, k is 0, so this is x to the 0 plus 0 plus 1. So this ends up being 1, 0 choose 0 is 1, times x. Now, I'm going to add on to that the term that I get from n is equal to 1, and now that is its own summation. I'm allowed to reuse k, because k is like a throwaway variable. So here n is equal to 1, so I have 1 choose k, x to the 1 plus k plus 1. So this is going to run when k is equal to 0, so I get 1 choose 0, x to the 1 plus 0 plus 1, plus, now it goes to 1 choose 1, x to the 1 plus 1 plus 1, so I'm going to get here 1 x squared plus x cubed. So far, so good. And then I'm going to go for n equals 2, and I get the sum from k equals 0 to 2. 2 choose k, x to the 1 plus 2 plus k plus 1. So I'm going to have 2 choose 0, x to the 2 plus 0 plus 1, plus 2 choose 1, x to the 2 plus 1 plus 1, plus 2 choose 2, x to the 2 plus 2 plus 1. And so far out of this, so far up to n equals 2, I have gotten 6 terms. And if I simplify them, this would be x cubed plus 2x to the 4th plus x to the 5th. And I'm going to keep doing this. I'm going to keep doing this over all n from n equals 0 to infinity. Another way that you might, and what you'll notice though is that you're going to pick up some terms from different n values that actually end up having the same exponent. So I have an x cubed here, and I have an x cubed here, and so when I actually expand this out, I'm going to have at least a 2x cubed. Let's think about this a different way. We could just start visualizing this as a triangle, and that's sort of what we were doing here. We're going to have 0 choose 0, x to the 0 plus 0 plus 1, plus 1 choose 0, x to the 1 plus 0 plus 1, plus 1 choose 1, x to the 1 plus 1 plus 1. So here n is 0, here n is 1, here k is 0, here k is 1, plus 2 choose 0, x to the 2 plus 0 plus 1, plus 2 choose 1, x to the 2 plus 1 plus 1, plus 2 choose 2, x to the 2 plus 2 plus 1, plus 3 choose 0, x to the 3 plus 0 plus 1, plus 3 choose 1, x to the 3 plus 1 plus 1, plus 3 choose 2, x to the 3 plus 2 plus 1, plus 3 choose 3, x to the 3 plus 3 plus 1. And this is going to continue forever. And so if I'm thinking about this as being a power series, what I need to do is I need to figure out how do these correspond to the x to the m. And one more way that it might be helpful for you to think about it is to think about this as a computational thing. So I could envision this power series f of mx to the m. I could envision an infinite list, like an infinite Python list, where I have an f of m spot, or an f of 0 spot, I have an f of 1 spot, I have an f of 2 spot, I have an f of 3 spot, etc. And the goal, of course, is to figure out what these numbers are. And then for a summation like this, I'm going to have a 4 n equals 0 to infinity. And then I'm going to have 4. So initially all of these are going to start out as 0. And then 4, k equals 0 to n. And what I'm going to add on is f of n plus k plus 1 should become equal to, I'm going to update it by adding on whatever n choose k is at that moment. So here are a couple of different ways to think about it. Now ultimately you can do some of the symbolic manipulation even if you don't have a good way to visualize it or think about it. But I think it's important to stop for a minute and just think about what it means when you have a finite sum inside an infinite sum. And then we're going to go on and actually do this calculation.